In this video, I will show examples on how to find the domain of a function given an equation, including radicals, fractions, and interval notation. I have another video on finding the domain given a graph. So let's look at this example, y equals x minus 10. So when you are finding the domain, what you're thinking about is what inputs can you put into this equation to get a real output? And in this case, there are absolutely no restrictions on x. You could plug in any x value for x, any fraction, any decimal, any number at all, and you would get a real output for y. So your domain then is all real numbers. In interval notation, we write that as negative infinity to infinity. In interval notation, you always use parentheses with negative infinity and infinity. The second example is y equals the sum of x and 12 squared. Are there any restrictions on what x could be, or could you plug in any number for x and get a real output for y? You could plug in anything for x and get a real output for y. What about the third example, x cubed plus 14? Again, you could plug in anything for x and get a real output. What about number 4, y equals the absolute value of x minus 15? You could plug in any number for x. So in all of these cases, your domain is all real numbers, or negative infinity, comma, infinity with parentheses. So let's talk about the two things that can affect or restrict the domain. The first thing that can affect and restrict the domain are even roots, like the square root, like if your function has y equals the square root of x, or the function is a fourth root of x, or your function is a sixth root of x. Because we know that the square root of 4 is 2, but the square root of negative 4 is an imaginary number, that is 2i. Check out my other video on imaginary numbers. We know the square root of 0 is 0. So when we're looking at a function like y equals the square root of x, then our domain, our set of inputs, is that x has to be greater than or equal to 0, because this number that's inside underneath this square root, the radicand, that has to be 0 or a positive number. This number cannot be negative, because then you don't get a real output, you get an imaginary output, and therefore your domain is restricted to only these inputs. Only these x values can go in here. Now let's talk about what this is in interval notation, and then we'll talk a little bit more about like the fourth roots and sixth roots. When you're doing interval notation, it can really help to think about a number line. So if this is 0, all your negative numbers are to the left of 0, and all your positive numbers are to the right of 0. And so all real numbers covers all the negative numbers to infinity, and to the right are all your positive numbers to positive infinity. But if your domain can only be x is greater than or equal to 0, then you're starting here and you're only going in this direction to positive infinity. So the way we write this is with a bracket, 0, comma, infinity, parentheses, because infinity always uses parentheses because it's not a set number. But 0 will have a bracket because of this equal sign right here. Your domain includes 0, so therefore you have a bracket. Your domain for the fourth root of x will also be x is greater than or equal to 0, because any number times itself 4 times will be a positive number, or 0. The fourth root of 0 is also 0. Same thing for the sixth root. Sixth root of 0 is 0, because 0 times itself 6 times is still 0. And any number times itself 6 times will be a positive number. Now this does not apply to odd roots, so let's talk about that for just a minute. So let's look at the function y equals the cube root of x. So can we put in negative numbers for x in a cube root? Yes, we can. For example, the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So you can find a number that times itself 3 times is a negative number. You can also take the cube root of 0, and that's 0. You can also take the cube root of a positive number, like 8, and that's 2. And so when you have y equals a cube root of x, your domain would still be all real numbers, or negative infinity to infinity. And this applies to any odd number in the index, which is in this spot right here. The second thing that can have an effect or restrict the domain is when you have a variable in the denominator. For example, if you have y equals 1 over x, then x cannot equal 0, because if you have 0 in the denominator, it makes your function undefined. Let's also write x cannot equal 0 in interval notation. So again, thinking about our number line, negative infinity is over here, infinity is over here. There's just this one value that x cannot equal, which is 0. So when you're writing an interval notation, you're going to go from negative infinity up to 0, and then you're going to exclude just that one value, and then you'll go from 0 to infinity to make sure you're covering all the negative numbers that could be an input and all the positive numbers that could be an input. So we'll do negative infinity, comma, 0 with a parentheses, and we're going to union this with 0 to infinity. Now notice that this has parentheses around 0 because 0 is not included. This big U, this union, is just something you do if you have more than one set of parentheses, then you just put this in between them. It's set notation, but you just union to show, okay, it's any x value that's in here or in this one. Now let's look at a bunch more examples on how to find the domain. The function y equals 1/2 x. Now this is 1/2 times x, and x is really technically over 1. So x is not in the denominator, so what is your domain? All real numbers, x can be anything, negative infinity to infinity. Remembering that the domain for y equals the square root of x is bracket 0 to infinity will help us with the next example. Remember here that x would have to be 0 or a positive number in order to get a real output for y. For the function y equals 1 over the square root of x, this x value here, since it has the square root, usually has to be greater than or equal to 0. However, it's in the denominator of a fraction, so it cannot equal 0 because that would make the function undefined there. So our domain is that x has to be greater than 0. The way that we write that in interval notation is parentheses 0 to infinity, and this parentheses shows that 0 is not included, whereas this bracket here shows that 0 is included with this equal sign here. For the fourth example, we'll look at y equals the square root of x minus 5. This is all underneath the square root. So this whole entire thing, x minus 5, has to be greater than or equal to 0. So we can add 5 to both sides to get that x is greater than or equal to 5. To write that in interval notation, we would do a bracket around 5 since we do have an equal sign here. 5 and greater than will be to the right to infinity. The next example is y equals the square root of 8 minus x. This whole thing is under the square root, so we're going to set 8 minus x greater than or equal to 0. That quantity has to be 0 or greater in order to take the square root and get a real number. So we'll subtract 8 from both sides, and then we'll divide both sides by -1. When you divide or multiply by a negative number when you're solving an inequality, you have to flip the sign. So x is less than or equal to 8. So the less than means that we're going towards negative infinity, and 8 is included since it's the equal sign, so that has a bracket around it. For y equals 1 over the square root of x minus 11, we know that this quantity under the root would have to be greater than or equal to 0. However, since it's in the denominator of a fraction, it cannot equal 0. So we can set x minus 11 greater to 0. Not greater than or equal to, just greater than. We can add 11 to both sides and get the x has to be greater than 11. So to write that in interval notation, we would go from 11, and since we're going greater than 11, we're headed towards infinity. Parentheses around the 11, and of course parentheses around the infinity. If you feel comfortable, go ahead and pause the video and do this next example on your own, and then check your work. So we have y equals 1 over the square root of 7 minus x. That means that 7 minus x has to be greater than 0 since it's under a square root. So we'll subtract 7 on both sides, and then since we're dividing by -1, we flip the inequality. So x is less than 7. To write that in interval notation, since it's less than, it would be headed towards negative infinity, and it would go only up until 7, and 7 is not included, so we put a parentheses. Remembering that the domain of y equals the cube root of x would be all real numbers, because we can take the cube root of a negative number will help us in this next example. Y equals 1 over the cube root of x. Well, you can take the cube root of any number, positive or negative, but you cannot have 0 in the denominator, so x cannot equal 0. So we would go from negative infinity, comma 0, parentheses, and we'll union that with 0 to infinity, like we did for 1 over x. For our next example, y equals 1 over x plus 2. So what can x not equal? What would make the denominator 0? Now, of course, you could always set your denominator equal to 0 to solve for it, to actually algebraically solve for it. So you subtract 2 on both sides, and you know that x cannot equal that value because that would make the denominator 0, even though you probably saw right away that it was -2. So how would you write that in interval notation? Go ahead and pause the video and then check your answer. So you would go from negative infinity to -2, parentheses, union that, pick right back up after -2, and go all the way to infinity. For the next example, y equals 1 over the cube root of x plus 5. Go ahead and pause the video and check your answer for the domain. Since it's a cube root, we don't have restrictions on positive or negative, but this cannot equal 0. So x cannot equal -5. So in interval notation, we'll go from negative infinity to -5, and then union that with -5 to infinity. The next example, y equals 1 over x squared plus 9x plus 8. It might be a little bit harder to figure out what would make the denominator 0. So you can set your denominator equal to 0 and solve for it. So In order to solve a quadratic equation, you can use factoring or quadratic formula or even graphing. But this one is fairly easy to factor, so you probably want to solve it by factoring. This is x plus 8 times x plus 1 equals 0. And so x plus 8 equals 0 would give you a solution, which is x is negative 8. And x plus 1 would also give you a solution, which is x is negative 1. And so, because 0 times any number is 0. So, for your domain, x cannot equal negative 8. It also cannot equal negative 1 because those two values would make your denominator 0. So if you think about it on a number line, you have negative 8 over here and negative 1 over here. So you need to split it up into these three intervals. So you have negative infinity to negative 8, parentheses. You're going to union that from negative 8 to negative 1, and then you'll union that again from negative 1 to positive infinity. And this shows that negative 8 is not included and negative 1 is also not included. Our next example is y equals 1 over x squared minus 16. If you're thinking about what makes the denominator 0, you would hopefully think about x equals 4, but you would hopefully also not forget about the other solution, negative 4, because negative 4 squared is also 16. One of the ways to make sure that you don't forget that you do have two solutions here is to factor. This is a difference of two squares, so you can factor x minus 4 times x plus 4. And then you can get your two solutions, x equals positive 4 and x equals negative 4. Now you know that for your domain, that x cannot equal negative 4 or 4. So go ahead and pause the video and write that in interval notation and then check your work. You would go from negative infinity to negative 4. It's very important to do these in order, so we definitely need negative 4 here first. And then we'll go from negative 4 to 4, and then we'll go from 4 to infinity. The way that you write these is really just like your number line. You have negative 4 over here and 4 over here, and negative infinity way out here and infinity way out here. So you do this interval, then this interval, then this interval. You must write it in the order of the number line. I have two more examples for you. But this one, y equals 1 over x squared plus 4. Now, you see the fraction, so you think, well, what would make the denominator 0? And you might be able to see right away that nothing is going to make your denominator 0. But if you wanted to, you could set your denominator equal to 0 and solve to see if you could solve it. So you would get x squared equals negative 4. Well, that can't happen. A squared number is never going to equal a negative number. So this is not solvable. Okay, there's no solution to this. So that means that your domain is all real numbers, negative infinity to infinity. You could put any number in here because x squared will never equal negative 4, and therefore your denominator will never be 0. In this example, y equals 1 over 4x plus 12, you may be able to see right away what x cannot equal because it would make the denominator 0. If you don't, just set it up. 4x plus 12 equals 0 to see what x value would make it 0. 4x is equal to negative 12 and x is negative 3. So for your domain, x cannot equal negative 3, which means in interval notation, it goes from negative infinity to negative 3, and you union that with negative 3 to infinity. I hope you've enjoyed this video. Please like, subscribe, and comment, and check out my other videos.